My name is Susan Kaler, and I'm from SAS, and I'll be your session host today. Welcome to the session, the Beneficiary Claims Data API, a real-world example of using SAS tools. This is going to be presented by Jack Shoemaker, who is a consultant with the Medical Home Network. Just one housekeeping tip. Please hold your questions until the end of the session. They've entrusted me with a microphone, and raise your hand and I'll be glad to hand the microphone over to you. So let's give a warm welcome to Jack.
Well, good morning, and thank you very much. I'd like to thank SAS for inviting me, and more importantly, I'd like to thank you folks out in the office, out in the audience, for spending at least part of your morning with us here. So this is, the point of this paper is just solving a business problem, in this case using this thing called the BCDA, using SAS tools. And just to get this out of the way, what this is the BCDA is an acronym for Benefit Claims Data API, and it is a RESTful API that is maintained and published by the U.S. federal government, and it provides access to administrative data. In the off chance if these acronyms mean anything to you, it's like CCLF data. As I said, it's managed by CMS, which is a public agency. And in this example, we're going to use SAS to use the API, which is meaning we're going to be submitting a request for the data. We need to monitor that request because it takes time for the job to build and complete. And then we are going to download the result, which in this case is a bunch of NDJSON files. So the tools that we're going to cover in particular is the SAS HTTP procedure, which is frankly a big wrapper for what would otherwise be, I guess, a curl command or however else you submit commands over the internet. The wonderful JSON live name engine that SAS provides, which is very handy for parsing data payloads that are in a JSON format. The use of the temporary file to pass state information from step to step, since this is a multi-step process, as you will see in a moment, and of course some data steps and a very small amount of macros. I will say this is pulled from some actual production code that runs today, and of course, not surprisingly, in the shop, it's got a lot of macro code. I hope that. I don't think it's going to be overwhelming here, but this is not a macro class, but there is a small amount of macro that you'll see. So what is an API? Just to make, in case it's not evident, if you saw it, if it was running down the street, it would look like a web address. It starts with usually HTTPS, like any other web address. It has three parts. The first part is the server. This is something that normally ends in a high-level domain name like .com or .gov that you're familiar with. Then there is a path to the actual service or program you're going to want to run using the API. And then optionally, the service or program itself may require or may accept, might be a better term, parameters, and those are sent as name-value pairs connected by ampersands and delineated from the other part of the URL with a question mark. Often what you get back is a JSON payload, and that is going to be the case in this exercise. And finally, to finish our definitions, what is JSON? JSON is a language, or I would say it's a way to represent data. It really has only two components. One is called an array. Unfortunately, this is not like the SAS array in the data step, but it's called an array. And the other one is called an object. And the object, I would say, is more commonly known as an associative array in that it has a left-hand side value that results in a right-hand side value. In both cases, either the array, which is the list, or the object itself, the right-hand side of the object, can be just single values like strings, or they can be, in fact, other arrays or objects. So as you might imagine, it provides a completely flexible structure if you have ragged data needs, meaning non-rectangular data needs, which is the case on what actually gets returned in this case from the API. All right. So we're going to break this down into a 5-step process. And this is actually kind of, I would say this is the authentication part of it is pretty common in this day and age, which is to say the first step is you have a username and password, or it may not be called a username and password, but it's the two values that you use as a username and password. And what you can do with that is you can request a token which has a relatively short expiry, and then all further data requests have to be done using the token, not the basic authentication. And so that is the case with the BCDA. The first thing you do is you need to get a token in order to carry out any of the subsequent steps. The second is you request the data. That's going to be just pushing out the request. The third is you need to wait. Although this is a RESTful API, under the covers, underneath everything, it's Apollo era technology. Seriously, it's been around forever. They've just put in a much nicer, they being CMS, a much nicer front end around it. But really, you are in the background. You are waiting for a job to complete on a mainframe computer somewhere buried in the government. Who knows? Anyway, it does complete, and we'll show you. We'll see how we determine that. And once it completes, you can locate the data. That is, you have a URI, a full path to the NDJSON file, and then we download the file to a local location. So, if you were to browse the documentation for the BCDA at the cms.gov website, and by the way, it's the documentation and all else is completely public, and in fact they even have a sandbox area if you want to fool around yourself. These examples do not use the sandbox; these are using the real place. In any event, you would see in the documentation that in order to get the token, you send a post command with the service auth token. And here is an example of doing it using curl from the command line. And if you did that, you would get back a JSON payload. It has 3 elements. It has the access token, the expiry amount, and the token type. The access token is what matters here. It's a long 652-character string in this case, and it's what we're going to use for the remaining parts of the exercise. Excuse me for 1 second. I hope clear as day. All right. So, at this point, how would we do this using SAS instead of curl directly? I've put the server, the host, the server in a macro symbol called host. I've put the service itself in a macro symbol called SVC, mainly to make the line that says URL equals easy to type. And in this case, again, as I said, we use basic authentication. You'll have to trust me that we make the username and password available as macro symbols, not part of this exercise, and that generates the 3-element payload that I showed you on the previous slide. In this case, we're sending it to just a SAS file, a file name with the reference response, and we're using the temporary device so that when this job terminates, this file will go away. But because really all we need it is in order to grab the token out of it. And for that, we will use the JSON LibName engine. In this case, we're creating a LibName called auth and specifying the LibName engine JSON. And we're using the file ref LibName option to point to the very response file that we have now loaded with the return from the auth token service. Now, at this point, there are rules. This is a very simple JSON payload. SAS has built-in rules for how it decides to break everything apart. You can look at the LibName auth like you might look at any other LibName, say with PROC data sets. After some inspection, we happen to know that there's always something called auth.root, and it has a value. It has something called access_token in it, and we use a simple data step to shove that value from the response file, the JSON payload, into a SAS macro symbol, which we will then use in the subsequent steps. And what would that look like? So now again, just to back up, at this point, we have used our basic authentication credentials to obtain an access token. We've placed that token in a SAS macro symbol called access_token. Now, here is a typical data request. The line that says the SVC is again from the documentation. There would be no way there's nothing generalized about that at all. That just happens to be the syntax of one of the endpoints that the BCDA supports. You'll notice that it has a question mark. So everything to the left of the question mark is what I would call the service call, and to the right of the question mark are the parameters. In this case, there's one parameter. Apparently, it's called _type, and it has a value of capital C coverage. Again, there's nothing. You only know that by looking at the documentation, but this is a service call that we want to run at this point. So in this case, again, we'll use PROC HTTP. The URL looks remarkably the same. What's different is that instead of using basic authorization, we use OAuth_bearer, and in there we supply the access token that we got on the previous step. And in this case, and this is really, I think, a wonderful feature of using PROC HTTP, because it splits out the header and the what would normally go to standard out separately. And in particular, in this case, we really want to look at the header that comes back from this. The response file is frankly empty when you just do the submit. One thing just to point out, and I won't get into this, but the HTTP procedure also generates two global macro symbols, which are, it's a mouthful, sys proc HTTP status code and sys proc HTTP status phrase, which you can use to make sure that the HTTP call itself worked as expected. We won't necessarily get into that, but we'll just keep that in mind. What we are interested in is the header. So the header is a set of name-value pairs that comes back, and one of the key values is content location, and then what content location has is the location of the files for the job that we've just created. And in this case, we happen to create job 87956. That will change from iteration to iteration. So again, because we do this, we can look at the header file. We're really only interested in the row where the key is content-location, and we are going to put the last node of the value of content location into a macro symbol called job ID. So we now have a job ID that we can pass on to the next step, which is waiting for the job to complete. Yeah. I'm sorry. It's just that this is the non-generalized part of this presentation. In any event, given a job ID, you can create a service line that says API v2 jobs and then job ID. Again, you only know that because you've read the documentation. But when you run this, what you'll get is either everything is working, or it's still in progress, or it's not. So in this case, we run the command to look for the job status. We look in the header, in this case for a key called x-progress, which is bad because when it's done, x-progress will not exist actually. So, and then we put that in a macro symbol called ready that we're going to test. The whole business with x-progress and the use of a macro symbol called ready, I mean, that's kind of up to you. The idea is that we interrogate the results of the call, and we set a macro symbol that we will then test, and if it says no, we will, in this case, we initiate a loop in which we sleep for 1,200 seconds, which is the %let_p business. And then this, by the way, this is, I think, a legitimate use of the go-to command, because what the go-to command will do is it basically goes to the top of this and looks again. Now, this will work for safety purposes. We arbitrarily only look 5 times so that we don't, spin off into Never Never Land. It often works. It doesn't work 100% of the time. Candidly, I wish there was a better way to know when the job is done, but such as it is. We do get a point where the job is done, and now we can actually go request the data. So when the job is done, the response file will actually have something in it, and it's not surprisingly, it's a JSON payload. So we will, using the same trick, we will now create a libname called BCDA. We will associate the JSON libname engine with that, and using the file ref equals option, we will point it to the response file that has now come from the successful checking of the status of our download. And in this case, you need to know, I mean, it just so happens that the data set called output is the one that has the URIs, the full address to the NDJSON files you want. Again, there's no way to know a priori that it's going to be, that it's called output. It just so happens in this setup, when SAS parses the JSON payload, the data set called output is the one that is of interest to us. So, I mean, you need to do a little checking, but once you know what it is constant after that. What the URI looks like is what's been assigned to the symbol U here. It's again, it's, notice up to now instead of jobs, it's data, and the job ID is 87956 again, and then the rest of it is a unique file name .ndjson, and in fact this is a full pointer to an NDJSON file. There will be, as a practical matter, there will be multiple of these. The output data set from before will have as many as the requests generated. But in each case, we need to just issue now a get command. We use that as the full URL. And in this case, we don't want to have a temporary response location. Rather, the response location in this case goes to the local or storage area where we want to download the NDJSON files to. So after all that, the waiting, we have some NDJSON files. By the way, we don't have SAS data sets or anything. We just have NDJSON files. So, oops. Let's grab this. Okay, so what are NDJSON files? Well, NDJSON files stands for New Line Delimited JSON, and what that means is every row in the file is a JSON payload as described in the JSON on a nutshell slide. The SAS JSON engine works on a payload. Well, that's what it expects. So the NDJSON format poses a challenge if you want to use SAS tools to parse it, because if you present just the whole file, which would make perfect sense, by the way, it will choke because it will look like an invalid JSON payload once it gets past it being SAS, once SAS gets past the first line. So, two strategies, at least two strategies available. Happy to hear if people have some other ones. One is that you can take the file, the JSON that you got back, the NDJSON you got back, and make it a gigantic JSON list or array, right? So start at, something equals, and put the left bracket there, substitute comma for all the new lines that you find in the file, and then put the closing bracket, and there you have it. That will be a single JSON payload as far as SAS is concerned, and then you can, you're either happy or not happy with the way that SAS handles the multi-line, the potentially ginormous payload. The other way to go about this is to say, well, we need to hand over one row at a time to SAS, or at least to the JSON live name engine, and that can be done through several mechanisms. In either case, I would say the common problem is that at some point you're going to end up with some appending going on, and field links are going to matter. And there's, again, this is, it's just, as long as you know what's happening, I guess you can usually make a good decision. Sometimes there's some shops that like to pre-specify what the length of everything is, and they make sure that they guarantee uniformity based on that. I've also seen sort of change the attributes on the fly strategy, which is, I don't know, coding for job security, I think. I don't know, but it works. But in all seriousness, I mean, if you have a simple file, a simple file, encapsulating the whole file makes a tremendous amount of sense because you let SAS do the heavy lifting. If you have an excessively nested JSON, which, by the way, is what is returned by the BCDA for several, well, at least one record type in particular, not the one in the example, but another one. You really, at that point, it's worth the candle to say, okay, we're going to just, go through this file one at a time, probably send it out somewhere, process that, and then, as I said, you're going to be faced with an append situation. I mean, not unlike what putting an entire JSON file will look like, such is the world. So that is all. That is what I have, and I'm happy to again thank you very much for attending and for your attention. I'd be happy to answer any questions or go over anything. Yes, sir.
I can run too.
Thank you, Jack. I appreciate you exposing this. I know there's a lot of sweat equity behind that because I've had the pleasure of dealing with JSON files as well in SAS. This is not an easy endeavor. So my question is, one, is there a way to view a JSON file before you retrieve it in SAS, via systemically, programmatically? Because, a native JSON file, it's longer than a Florida Python and requires a lot of deciphering, and so I've always needed something to help me understand the structure of the JSON file. And secondly, I was going to recommend for the NDJSON possibly a data step with an in-file statement and just read it in like a raw file. I don't know if it would work or not, but if you could get it in that way, I know that the in-file statement can read a lot of trash.
Okay, so let me address the second part first, which is that this presentation today is a stripped-down version of one that Samaya, a coworker at MHN, and I did it at a MW SUG. Anyway, her part is what to do with the damn NDJSON files, and it's what I was going to say. I mean, frankly, it's a separate talk because it's a thing unto itself. So this is how we have separated it. If I understand your question was, I have a file that has a JSON payload in it. How can I look at it before I suck it into SAS? Did I get it? Okay. So I would say, to me, that means you put it in an editor because it is just a plain old text file. I am a dinosaur. I use Emacs, which I don't know, that may mean nothing to anyone in the room, but I have an editor of choice. I mean, one that I'm familiar with. I mean, I think Notepad Plus, it would be fine. Anything that's any like basic text editor is going to work. Some of them will be and this will be useful. Some are like JSON aware, which means that it may color and/or indent the payload for readability. I mean, personally, I'm an Emacs user, but as I said. Thank you for that question. Everything was,
Okay, then we'll close the session. Thank you, Jack.
thank you.